Okay. Hi, everybody. Today we continue our work regarding logistic regression by using analytics and machine learning toolkit. In the previous lecture, we have examined in detail an example in which we have read the data set and loaded it, and after that it was pre-processed, and at the end it was exposed to the classification algorithm, and at the end of that we have got a model of the data set, and we saved that model as a JSON file in the computer. We have checked the example and found that it was learned correctly and it is ready to be used or deployed in the next step when required. Today we will work with the next step, which is the deployment of the worked out model. For that purpose, we have to import the required dataset, and this dataset must be as a CSV file, which is normal and easy to have it. Also, we need, of course, to make use of the saved model. For that purpose, we at first use the analytics machine learning read model from JSON VI. This VI, as you see here, is designed by LabVIEW specifically for this purpose. And it could be used anytime you want. You just open it and go to the front panel, select the icon here, and drag it and put it anywhere you want, and then you can use it in any block diagram. So, of course, if you want to have an idea about it, you can double-click it and go to the block diagram and have a look at all the components. I do not advise you to do that if it is not necessary. It is somehow a complicated work, and it is not required to repeat this activity. So I quit it. We go out of it and continue our work. So now this is the VI, which is called AML Analytics Machine Learning Read Model from JSON VI. This file is already saved in the computer, and I have shown you where it is in the previous lecture. In addition to reading this file, we have to read the data set, which is going to be used as a test data set. So we use for that also another sub-VI called AML read CSV file VI. Read CSV file. And you have an idea about this file in the previous lecture. I have shown it to you, and again, I can open it for you. It is also very similar to the previous one, nothing new. And now we have, sorry. Now we have an idea that it gives us the output after reading the data set itself, which is the features of the multinomial data set of iris and the labels associated with it. Both of them are fed to a transpose two-dimensional array and fed to insert into array. At the end here, you can come up to the array which includes the features and the targets or the labels. If I double click it here, and you can see here it is 5 columns, as you see, 4 columns, which is the sepal length and sepal width, and the yes, and the petal length and the petal width. The last one is the labels, but if you want to see it correctly, you need to transpose this array. I do not need that. I have just wanted to show you how it looks like. Now, after loading the data sets, as you see, we fit both the data, the features, and the labels to the load data two-dimensional array VI. This is the load data VI, which is standard, but you need to select here for deployment and not for training. Here it is selected for deployment and not for training. And how you can find it is easy. You go to the analytics and machine learning, and then you go to the data. Here is the load data VI. Instead of training, you select deployment, and you will have this VI, which is here. So now the data is fed to the load data VI, and it must be directly fed to the deploy classification model VI. Also, the deploy classification model, you go to classification, and here to deploy model. If you look at it, you will see that this is the same VI which we are talking about. But here, to generalize the work, here we use another VI used when we carry out feature manipulations or preparations, transforming. This is called deploy feature manipulation model VI. Also, it is there with the analytics. Sorry, we have to go to the feature manipulation. Here it is deploy model. It is this one, deploy feature manipulation model. this is used to the case when we use the preparation work with the features. Here is, as you see, this function here, which is called empty array. If it is filled array, the data will pass, the data which was processed will pass to the deploy feature manipulation model. If there is nothing, it will continue working passing the data directly to the deploy classification model, which is here. Now, at the output of the deploy classification model, you get the answer here. Here you have the labels, probabilities. Here is the predicted labels. Here they are. And downwards here, we have also the predicted probabilities for each class. The labels, as you see, are given in an array, one-dimensional array. Here it is. And of course, the size of this array will be 150. The size of the array, 150. And of course, this means 150 rows or 150 readings we shall have. One class will be 0, and the other class will be 1, and the third class will be 2. Of course, if you go down, if you pass here, let me put, sorry, first I have to stop this one. If I point here and go directly to number, let me directly go to number 48, for example, or 47, because I know in advance we still have zeros. Here 47 element, the index 47, 0, 48, 0, the 49 is 0. These are all one class. The second class now begins here, which is at about 49. Yes, at 50. Let me go back. At 50, it begins with the elements or the class which are having an index 1. And then you go also further. If I put here, let me put about 100. Yes. No, less than 100. Yes, 99 index will be still 1. At 100, we will begin with the second or the third class. So this is a way to look at it, but this is not an appropriate way. So really, I have worked out let me go back to the block diagram. Here I have taken the data from the block diagram, this array, and I have fed it to this structure, the for structure and the case structure inside each other. And the data which is coming now from that array will be checked through the search one-dimensional array. And as the output, I shall get the elements which are found, which is 0, 1, 2, and the count of each of them. If I go back to the front panel, I shall see here, this is the values which are belonging to each of the class. Class number 0, we have 50 values. Class number 1, we have 48 values. Class number 2, we have 52 values. If you take the sum of all of them, this will be the size of the data set, which is 150. 48 and 250, 50, 50, 50 will be 150. Really, it is 150. So the size of the array, 150 rows, and we shall have 3 classes. This is the result of deployment of the data set. This is the size of the data itself, which is the features, 150. It should be 150 because we have 150 rows. And here number 3, 0, 1, 2, 3, which are the petal and sepal length and width. Also, the program has a facility to check the degree of accuracy by using the evaluate classification model VI. Also, this is existing in this data set. Here the classification, here is the evaluate model. This is the same VI. We use the evaluate model VI, and the output is given here, which is about, the accuracy is about 97%, which is really very high. And as you see, if the whole set is 150, only we have 2 points, 2 values which are wrongly detected. If they are equally detected, 50 by 50 by 50, but here we have 48 and 52, which means only 2 points wrongly detected, and the other values are correct. So the accuracy of the deployment is very high. I have really tried also to find another graphical way to calculate these values. I have taken the real input labels and the predicted labels. I have bundled them with the number of the samples which I have, and I created a graph here, X against Y. Really, I have got what I want, but it is not that clear as I hoped. If you consider, here is the level 0, this is level number 1, this is level number 2. These are the classes which I have. The first class I have from 0 to about less than 60, of course. Here is the middle 50, 52. Here it is 48, and this is 50. You have, of course, to read them according to the scale here from 0, because each interval here is equal to 4 to 5. 5 by 4 elements will give 20. So here, as you see, this is 5 down. We will have about 45, but it is not that accurate. It is a little bit more than that, not seen by the eyes. Anyhow, this is a way to show also the same values here, but graphically and in a different way. Also, concerning the features here, really, also we have shown them here, as you see, instead of showing them as an array of values, I have shown them, this is one feature, this is the second feature, this is the third, this is the fourth, and of course you can. This is the red one, for example. I can show it as points. Now it is points. And every point here represents the ordinate for the given sample. For example, sample number 80 will have the value of sepal length and sepal width and petal length and petal width graphically. This is not required and this is not really that important, but maybe it gives it has some sense maybe. Also, really, I have tried to make another way of finding the values here. I have taken the labels here and the labels here. I have made an array of them. At least I have, at the end, I have come to this picture here, where also they are divided to three levels. This is the 0 level, this is the 1 level, and this is the 2 level. And here, really, it gives an idea. Here is about 50, from 0 to 50. This is the 0 level, which we have here. It is really 0 to 50. They are exactly the same. The last are here. From here to here, you have now to subtract this unit from here, and by scaling this one, you will get 52. This will be also 48 when subtracting this portion and this portion. Anyhow, this is not the heart of the thing, but it is a way of working with this program. So, as you see now, we have deployed the data set of interest, but here an important thing really I have to note that when we work with the test data set, it should have the same size, the same number of rows as the rows which we have saved in the JSON file. This is important. What is left to tell you today is, okay, now we have an idea about this. Let us go away from it. And now this is the front panel also, which is not necessary for us. Don't save. Okay, now let us work with this example here, which is really a total. It is a complete picture where we have the classification part, where we read and learn the data set, and at the end we create the JSON model. This part has been shown to you in the previous lecture. And the other part where we deploy this data set, which I have explained to you today. We can connect both of them together. As you see here, the output from the train classification model VI, here it is, this is the reference number. Now I connect it with the analytics machine learning save model. This is already from the previous part. And this is the new thing, which I connected to the load data two-dimensional VI. Now this is the test data set which I am going to work on. When I run this program now, I have created a model and saved this model as JSON file, and at the same time, continuously, without calling anything, this part will be initiated, and with this data will be read and loaded and will be utilized to get an output showing the classification data. So if I go, let me go to the windows and to the front panel here. This is the front panel now, which I have got for this case. Here we have, as you see, 3 classes. We have the same data. Let us see, the accuracy is 97, exactly the same. This is the array of data and labels. This is the transposed array. This part represents the labels. If I run it now, if I run it, I shall have exactly the same data. Okay, so I don't know if you found that working with the analytics and machine learning is easier and more interesting for you, or working with the LabVIEW based play data library. I don't know. It is a matter of interest here, but as I felt, I have found that working with the play is more familiar to me, and I found it more appropriate. Anyhow, it depends on your taste. Okay, now we have practically finished with logistic regression basics by using the Python and by using play library and by using the analytics and machine learning. Well, we shall see what we can do further. We shall, I think, try to explore how other algorithms work with logistic regression for the sake of comparison and knowledge about their behavior. Okay, thank you for listening and see you in the coming lecture.